Okay, cool. Hi, everyone. Welcome to this talk. It's called Rock Solid React Apps for People in a Hurry. My name is Ryan, and I am the founder of a product called CourseLift. That is one of a few things that I do. I run a small agency as well. We build software for companies. I'm working on this product that is helpful for course authors when making their courses. But I'm not going to talk to you specifically about CourseLift or any of that other stuff today. What I want to talk to you about instead is a way to think about building React apps in maybe a way that is a bit quicker than what we might be used to. As I was preparing for this talk, I was thinking about this talk that I had done a few years back. I guess this is actually more than a few years back. This is 2017. This is a GraphQL Summit in San Francisco. And this was an important talk, I think, in my short talk career, because up to this point, this was kind of the biggest talk that I had done. This was, a really hot topic at the time, GraphQL, a lot of excitement around it. And this was like the biggest audience at the time that I had given a talk to. So, it was a big deal for me, this talk. So that was one reason. The other reason, though, is that this was right as I was on the cusp of some changes in my career, some shuffle to the things that I was doing professionally. And it's very hard to see at this angle and at this resolution, but that's that shirt that I'm wearing there, that's an Auth0 shirt. And at this time, I was working for Auth0. I was creating content for them, doing talks, doing developer relations related stuff. And this was a talk about authentication and security for GraphQL APIs specifically. So right as I was giving this talk, I was actually changing things up in my career to go out on my own. This is something that I had always wanted to do. I'd always wanted to be in business for myself, do things on my own, and this was an opportunity for me to do it. So right as this talk was finishing up, I was talking to some people at the conference, and they were saying, Auth0 is doing great. There's lots of really cool stuff going on in the Auth0 world. And I said, yeah, but I'm right about to leave. I'm right about to go do some other stuff. And so this led me into a project that was for a client that I got introduced to. I got introduced to this client kind of through a referral. And this client that I got introduced to was, they had a lot of technology challenges. They had a lot of things going on in their organization that were tough. They were doing things in backwards ways. They were transcribing data 2-3 times to get to a final endpoint. And I got referred to this client to build something good for them. And that was, it was a good challenge for me, because I said, this is something I've always wanted to do. I've always wanted to go out on my own and build software. And this sounds like a perfect opportunity. And the fee attached to it was not so bad too. So something approaching, not 7 figures, but 6 figures rather. And they said, this project, it's about a 5-month project. That's when we want you to be complete. And I said, okay, 5 months. I'm sure I can complete this in maybe 2 or 3. That sounds about reasonable. And maybe if I can find another project after this that's like a 2 or 3 month project at that rate, if I can do 2 or 3 of these a year, that's quite a few salaries or approximate salaries in a year. And that was what I thought would happen. As you probably can tell, it did not happen quite like that. It didn't happen in the 5 months that I was initially allotted, and it didn't even happen in the 12-month year period that followed. We eventually did get it done. Everything went fine, and the client is still a client of mine to this day. I've been serving them for over 5 years now. It is they've been great to me. They're a very good client. Very happy to have them. But I got to thinking about why things didn't go so well with that project in the initial phases. And there's all sorts of reasons that projects take a long time. They're kind of not scoped well, or the requirements aren't very clear. There's lots of reasons that projects start off on a bad foot. In my specific case, there were 3, I think, buckets that I could bucket things into for why the time was not so well spent when things started to take a long time. The first one is that I chose a database that just was not a good fit for this project. So fighting with MongoDB was a big portion of this time not so well spent. The reason for that, I think, is that I was approaching Mongo in a way that a relational database developer would. I was trying to use it in a way that a relational database developer would. And if you have used Mongo before, you might know that it's a different paradigm. It's not something that you use in the same way. So I was doing things like trying to relate collections together and trying to populate between collections, trying to then figure out why I had bottlenecks in my queries, stuff like that. MongoDB, not such a great choice. Another big chunk of time spent, kind of wasted, I suppose, was trying to figure out the actual requirements of this project. So, this client, they had grand visions for this product that they wanted, and they gave a pretty clear indication of like what it needed to do and all that. But underneath all of the kind of higher level requirements were a whole subset of technical details that they just failed to initially mention, and so therefore things were not scoped correctly, and I was spending time trying to figure out what they actually needed. But this third bucket, I think, is the most kind of like, looking back, significant portion of wasted time for me. And that was about a third of this wasted time is like, it was time spent gluing stuff together. And so what I mean by that is taking all of the pieces of technology that went into this application, this set of applications, and trying to figure out how to piece them together. So this specific project, it's an Angular front end, a Node.js back end, GraphQL API, MongoDB for the database. And figuring out the best ways to actually piece all of those things together was a big battle. And so, that looked like me trying to figure out the best file structure, for example, for especially the API side of the project. Trying to figure out like the best kind of structure for my GraphQL layer. Trying to figure out how to architect all of these pieces so that they were workable for not only myself, but other developers, and that it would be something that's long lasting. So gluing all this stuff together was a big pain. And at the end of this project, I said, I am not going to do things, at least like that, again. I don't want to spend time, fighting with MongoDB. I don't want to spend time refiguring out what the requirements are. And I also don't want to spend time trying to make this bespoke kind of environment for myself where I'm gluing all of these different pieces together. So, to that end, I would say that it's time for myself and for a lot of developers who are in similar situations to start to embrace full stack frameworks. But the first question you got to ask yourself is, what exactly is a full stack framework? I think a framework has a few different indicators. They might be things like something that provides you guardrails. So a framework, a library, a set of libraries that give you certain paths to follow that give you guidance as you're building your applications. Something that does the hard stuff for you. So there are certain frameworks out there that will, upon a command, will generate a bunch of code to help you talk to different APIs or handle hard stuff like mail for you, for example, email. They tie together different parts of the stack. So different concerns between the front ends and the back ends. A framework would be something that ties these things together. And then finally, I think if it says it's a framework, then it's probably a framework. That's at least my indicator. So the irony of all this, kind of going back to the initial story there, is that I was actually using Laravel before I had gotten into stuff like Angular and Node.js. I was using Laravel to build other smaller applications. And there's other great stuff like Rails, tried and true, battle tested. Same with Laravel. I could have chosen one of these. I could have probably saved myself a lot of headache. But it was in this era where Angular is really popular, React is getting very popular. Same with like GraphQL, Node.js, and there's this desire to build something with those technologies because it's it's the newer stuff, it's more modern perhaps, and all the typical reasons the JavaScript developers get into trouble, whereas they should probably just pick one of these things that's tried and true. But beyond Rails, beyond Laravel, and things like it, I'm guessing. So we're at a conference where there's a lot of .NET, and I'm assuming .NET is another one that falls into that bucket. I don't have experience with it myself. But when you step outside of that stuff and you look at like React, for example, Very often, at least up until this point in history, I think, the notion has been that you're kind of on your own when you're building a React application. And so React, not so much a framework, more so a library for building user interfaces. But if you want to use it in a framework-like fashion, you're kind of on your own as to how those things get pieced together between React, between some kind of backend, etc. And so for Laravel, for Rails, very often it would be the case that you would use one of those tools for, like an API for a backend, and you'd want to throw React on top, or you'd want to sprinkle React within your Laravel or your Rails application. But I think we're now in this new age. We are in this age of what I'll call the front-end focused full stack framework. And that's a lot of F's in a row, but I think we are there. And we have certain examples that I'm sure you've heard of. Next.js. It is what I would consider a full stack framework that is front-end focused. So Next.js sits on top of React, focuses on things like server-side rendering, so making turning your typically client-side dynamic pages into something that's server-side rendered, good for SEO and all of that. Focuses also on static site generation, so that you can get a static page out of what you can pre-render, and then you can just host it on something like Netlify, and it's statically there. A simple backend API layer. So within the Next.js project, you can have this API directory where you can then create functions that will run on a serverless function provider if you deploy it. And so it's a really simple way to get like a backend into the mix. But I guess Next.js falls a little bit short of being a complete framework for a full stack application that is concerned with React. Something that has come in the last couple of years is this framework called Blitz. And Blitz is what I'll call a meta framework because it sits on top of Next.js, which sits on top of React. So we're getting all these layers on top of one another, which is typical for programming. But Blitz.js, this kind of meta framework, focuses a lot on data models. So modeling your data is where you might start with Blitz. It has things that you would see in other frameworks like Laravel or Rails, where it's got like authentication that gets built in for you, really easy to do. And it's got this type-safe API layer as well. What I'll talk about today, though, is this other one that has been very beneficial for me in my work. For CourseLift, the product that I'm building, it's also very beneficial for my agency, and we use it in all of our projects now. Redwood is one of these things that kind of wraps React and many other technologies, but it goes a bit further. So it's very highly opinionated to start. That's kind of one of the things that I really like about it, is that it's a framework that gives you guardrails, and gives you guidance in all sorts of endeavors that you're going to have in your application. It's very highly opinionated. It makes decisions for you, and so you opt into those sorts of things. But if you do, you're well taken care of. Brings together lots of existing technologies that developers love, which we're going to take a look at in a minute. It's got really consistent patterns. So once you've learned a few of the patterns in Redwood that are important, you'll be able to repeat those kind of off memory, and you'll be able to work very fast. And this is the best thing, is that it just has so many time-saving features between things like generators and the abstractions that it has and patterns that it has in the code architecture. You're going to save a lot of time using it. These are the specific technologies that it wraps. So React, of course, for your front end. Then a Node.js API is default, and then a GraphQL API layer to communicate between them. For data modeling, that one down there in the bottom left is Prisma. So you start your data modeling with Prisma, and that will give you everything you need to then produce the artifacts that will be useful for making a GraphQL API and its associated resolvers, and then being able to communicate between your React frontend and your Node.js backend through that. Very good on the testing front. Storybook comes by default, as does Jest for unit testing. That is the basis of RedwoodJS. So this is Tom Preston Werner. You may recognize him if you're familiar with GitHub or some of the other projects that he has been involved in. So he's co-founder of GitHub, and he's the founder of RedwoodJS. So he's behind the project largely. And I sat down with him before the talk to ask him a few questions, and so we're gonna hear a little bit from Tom right now on this question. Why were these specific technologies chosen for Redwood? So let's hear from Tom here.
When we started Redwood,
maybe I have to put my mic up to the speaker.
Over 2 years ago, 2.5, 3 years ago, we wanted to use a stack of technologies that was already commonly used so that it would be easy for people to adopt Redwood. I've seen before many times people want to create a brand new technology and start everything over from scratch, inventing every single thing that they use, which can be powerful, but it makes it very difficult for people to then migrate to that because it becomes too risky. So we wanted to take a set of technologies that was already battle tested and proven and that people loved and integrate them in a really first-class kind of a way, and then add a lot of developer experience on top of that. And so that's really why we chose React, the most popular front-end rendering library for that, GraphQL as a transport protocol, JavaScript or TypeScript on the back end. All of these things, Storybook, Jest, really first-class options that people had already been using. Just integrate them better than anyone had ever integrated them before.
All right, so get back over the slides here. So yeah, the message there largely is that these are all technologies that people are working with already. They are popular, they're well used, people like them, they want to work with them, but they are by their nature disconnected. There isn't a coherent story for integrating them. You're kind of rolling your own every time you go to integrate them. And that's where RedwoodJS comes in. So, what does Redwood do then? Does it just install all of the dependencies for all of these libraries and, get you a few files in your file system? No, it goes well beyond that. Redwood brings a lot of things to the table. The first one that is, I think, one of the most beneficial things, especially as you're starting out your projects, would be generators. So you may have seen generators before if you've worked with many technologies. Angular is one that comes to mind. You can generate components for yourself via the command line. Redwood has a very robust generator story. There's lots of different ways you can generate all of the different types of artifacts that you are interested in. Scaffolding, which is basically a way to tell Redwood to generate all of the stuff you need for a full end-to-end CRUD system based on a resource. So you might start with like a data resource, something like a users table, for example. And with a single command, you can generate all of the stuff that would go into doing all your create, read, update, and delete for that. Authentication, so you can run a command to set up authentication targeting different auth providers. Auth0 is one of them. There's lots of other ones. You can do database authentication, so you don't have to actually use an outside provider. But there is a bespoke setup for many different authentication providers that you would otherwise be spending time kind of doing all that wiring for yourself. This is a big piece that would go into projects for me that I'd spend a lot of time on. I worked at Auth0 for 2.5 years. I knew how to wire up authentication between a front end and a back end pretty easily, but I would still spend a day or 2 days making sure it's just right in new projects. Redwood, on the other hand, has already done that for me. Routing is a big one. When you generate something like a page in Redwood, we'll see this a little bit later, the routes file gets updated for you. There's this kind of, I don't know if you'd call it a divide, but there's a bit of a difference in opinion right now in the React community when it comes to how routing operates. So things like Next.js, things like Remix, they have file system-based routing. So you create a set of files based on a certain folder structure, and the framework then is going to interpret how to set up your route structure for you. There are people that like that sort of approach. There are others that want to be very explicit about how routing is set up. With Redwood, it's the latter. You have a routes file, and you're going to set up your routes, describe them, order them in the way you want, and give them the behavior they should have. Layouts. This is kind of like a typical table stakes thing for most applications. You're going to want to have a layout of some sort. You're going to probably want to have multiple layouts if you're doing something that's got any sort of complexity to it. A layout you might think of as like my navbar or my sidebar, and then stuff that goes in the middle. So the layout is the wrapper portion of that. And when things get complex, you'd have a layout that regular users could see. You'd have a layout that admin users can see. And you'd have many kind of conditions that might tell you which layout to show. Code mods are a big one with RedwoodJS. They're great if you have if there's an update that comes, and Redwood updates quite regularly, following semantic versioning quite closely. So you'll often see a major version bump. They always provide a code mod to get yourself to the current state. So upgrading your project to the latest version is actually quite simple. You run a couple commands and it'll change your code for you to reflect the current state of the framework. And this is one that I've been torn on before, but I quite like it now: mono repos. Again, differences in opinion about whether this is a good thing or not. But what I can say after working with Redwood for some time now is that the way that I used to do things, where I'd have like my Angular front end in one directory, one project, and then my back end in another, and then maybe some other like ancillary project structures elsewhere, and then having to push to an individual repo for each of those, and then have to figure out deployment against each of those repos, it becomes much simpler when you move to a mono repo. So there's a lot of talk about mono repos, things like Turbo Repo these days, things like NX workspaces. Redwood uses Yarn workspaces to achieve a mono repo setup. And what it looks like, we'll see this kind of in practice, but what you get with Redwood is, oh yes, and custom patterns is another one that I was going to talk about, which come by way of things called cells. And so the cells is a custom pattern, which we'll take a look at. But the mono repo structure, I'll talk about it in this slide here. A Redwood project comes with two sides, is what they're called. So you've got your web side and your API side. Web side does what you think it might, holds a React project, and holds components and other artifacts that are relevant to what gets shipped to the client. Then there's this API directory for your API stuff. So this is where your Node.js code is going to sit. This is where your GraphQL implementation is. So any kind of schema files that you've got, or any resolvers to make your API accessible, they would reside in this API side. These are some of the kind of more common generators that you'll see in a Redwood project. This is the pattern. You're going to use yarn and target the Redwood command. Yarn Redwood generate, and then you say what you want to generate. So give it component and say the component name, and then Redwood takes care of the rest. Similar for a page. So a page is another structure within Redwood, kind of like a top-level structure, which is different from a component because pages, when you generate them, you are given then all of the structure you need for routing to that page. And we'll see that in action in a little bit here. And then you can generate a layout. So again, going back to what I was just mentioning, a layout being maybe your navbar and your sidebar on the top. You can generate a layout with a similar command. So you can see the pattern emerging here, right? Yarn, Redwood, generate the thing you want to generate, and then give it a name. This is the kind of structure here that we were talking about just a second ago. So layout being kind of the outermost layer of things, if you will. A page then would sit inside a layout, and a page is relevant because it is routable. Redwood can be made known about where the page is, what it's called, how to get to it, etc. And then individual components would live inside of a page. This is kind of the typical structure. And the thing that I always go back to is like this kind of concept is what I would arrive at myself, just kind of thinking through how a project should be structured. And this kind of structure is what I would get to on my own by implementing things myself. But the really cool thing here is that Redwood already has it done for me, so I don't need to spend time going through all of the motions to get there. Flipping to the back end of things now, this is something that's concerned with the API side. So an SDL, schema definition language, this is a GraphQL relevant topic. what you would do if you had some kind of resource. You got to start with a resource in your data model. So if you had like a table, a model called users, let's say, you could then generate an SDL for it, which would give you your GraphQL schema definition language and give you a set of resolvers to access your data. So basically, this command is going to generate that portion of the API for you. So that portion of the API will be generated, and you'll be good to go. So we'll hear from Tom again. The question that I asked him this time is, what does Redwood bring that's new or novel? We've taken a look at a few of those things, but what does it bring that's new, novel, rather than just tying together different existing pieces of technology?
And especially things around maintainability. So one thing that we try to do is make data fetching really easy, and then allow you to test and use those components in Storybook easily as well, bringing the experience all the way through the framework. So a cell is a declarative way to do data fetching. So you'll have a component, a React component that you're building, and if that needs data, or if its children need data, then you can use what's called a cell in RedwoodJS. And that's a way to declaratively state, here is my query, my GraphQL query. Here is my success state. Here's my loading state. Here's a failure state. Even here's an empty result set state. All of these states then are just exported from a React component file, which makes it really easy to then test them independently using the improvements that we've added to Jest, as well as see them in Storybook, along with an entire mocking facility that we've added so that you can get them set up in Storybook and be able to see and work on your components by just mocking out what the network result would be, what the response of a GraphQL call would be. And you can have multiple different mocks and call on those to be viewed in your Storybook file. This is one of the hardest parts about using Storybook is how do you get a component that is doing data fetching to be able to render in Storybook is a non-trivial thing. And so this mentality of just adding improvements and then weaving them through the entire software development lifecycle within Redwood is a big part of that. On the other side, maintainability for the long term is really important. So this has driven a lot of the decisions that we've made on the back end, on the API side, that is an implementation of a GraphQL API. So we have something called services, what we call them, not microservices where everything's like separated and on a different server, but services within the context of a single Node.js runtime. We just use them as a logical separation for your logic, where you can say everything that belongs to a user's, a user profile, setting up a user, reading information about a user, that might all be in what we call a user service. And then anything that wants access to or needs to change something about the user is going to go through that service, which reduces the amount of coupling that you have between your services, allowing you better velocity as you continue development, as you increase the size of your teams, and as your code base grows and grows over time. And we do this because we really want to make it easy for you to use RedwoodJS in the long run, and especially for startups. We put a lot of emphasis on helping startups getting going, giving them the technology, the connections. We work with startups individually. We connect them with VCs if they're raising money. We really are thinking a lot about the startup journey and what we can do to help people, or anyone that's building a project that kind of looks like a startup. Maybe you're not raising money, that's fine. Really, it's about the experience of creating something from scratch and then building it over many years to become something really powerful.
All right. Oops. Okay, so that's a lot of talk about Redwood. Lots of descriptions, but it's probably useful if we see how it actually works, I think. So why don't we do that? I'm going to get myself over to this repo here and make sure first that everybody can see it. I think this looks decent, but if anyone's having trouble seeing it, just let me know. All right, so what I've got here is an already generated Redwood project. So two of the things of note here, you can see them immediately. One is this web directory, so that's the web side that I mentioned. The other is this API directory for the API side. We'll dive in a little bit further to what those are, but first I guess I'll show like how you would even get to this point in the first place. And what I'll show you here is I ran a command before this. I'm not going to set up the demo repo right now because it takes a couple of minutes to run. But the command anyway it looks like this: yarn create Redwood app, and then you give it a name. I always go for -- TypeScript. I'm all in on TypeScript. That is, I think, going to give you a ton of benefit both on the front end and the back end. So you'd run this command, and you would get yourself a Redwood app. Then once you've got it, again, it's going to look something like this. So what can you do with this? Well, the first thing that I typically do is, maybe what I want to do is just run the app right off the bat. So for that, you can do yarn redwood, or shortened to RW, redwood dev. And that's going to give you a development server. So we'll see this pop up in just a minute. It should open up the app in a browser. And it sure does. So this is the default splash page you'll get to. Nothing really is going on in the app right now, and so we've got to tell it to do some stuff for us. And the first thing we might want to do is generate a page. So let's do yarn redwood G for generate. You can also type it out all the way, but you can just do G for generate a page, and let's have a page called home. So we get our page created. You can see that it's generating files for us. If we go into the website and we go to the source directory into pages, we'll see our home page. It's right there. We should get something now in the browser that tells us about that. And here is our list of pages. So we can navigate to this newly created home page that we just did. So things are working well there. What I'll show is this routes.tsx file. So this is on the website. This is our routes directory that React is concerned with. And Redwood has its own router. It comes with, Redwood wraps a whole bunch of technologies and kind of like does some stuff and re-exports them. But this is one aspect of Redwood that is custom, that it brings to the table that's fresh, is this routing system. And it's got some nice APIs. I mean, if you've used React and if you've used like Reach router or any of the popular ones, then there are some commonalities. But I think Redwood does a really good job with some of the APIs that it's got around routing. So we've got our homepage. This got automatically put into our routes file for us. So a time-saving thing. It might seem trivial, but like the time it takes once you get lots of routes coming in here and declaring your route by yourself, typing it all out, importing the components that you need, that time really does add up. So having it be put in for you is great. We might want to have our homepage exist within a specific layout. So we can do yarn redwood G layout this time, and maybe we want to have a layout called app. So just our one and only app layout in this case. It goes into the layouts directory. Here's app layout. And as you'll see with like any kind of component generation, these are React components. Any kind of component generation will give you the actual file for the component itself, but also a unit testing file, which uses Jest to run unit tests. And so, an already completed unit test that's there for you. And then also a storybook story. So you can run storybook with a Redwood command to get storybook spun up for you, and you can start developing against your components that way. So here's app layout, and what we could do with this. So children comes in as a prop, so wherever we apply this layout, will then pass through any of the children's, and those would be pages in this case. So the typical thing that you might do is something like, I don't know, give yourself a section. And I'm not probably being very semantic here with HTML, so forgive me, but you might have like a nav bar with some kind of list item. I'll just put it in a p tag for now. And maybe you've got this styled in a certain way. Maybe the background, where my background color is blue, and maybe the height is like 30 pixels. So then you've got your nav bar, you've got your children. Where you would apply your layout now is if you come to the routes file and you look for the route that you want, you can wrap what's called a set around it. And a set comes from RedwoodJS router. And this says that we want to group together certain pages and kind of apply some behavior to them. And what you might do is you might want to wrap that set with app layout. And doing that will give you your beautiful nav bar at the top and your pages within. So what that means is, like, if you had another page called About, for example, you could generate that page. It's going to pop itself into the routes file there. We could then wrap the About page within that set. And now if we go to About as well, it's going to have that nav bar applied. So very handy in that way. So, I mean, like, one of the takeaways even at this point is that all of this stuff, like, this is all stuff that I would do in the apps that I would build, but it would take me, I mean, I would be on like day 2 at this point, kind of wiring all this stuff together, whereas I just did this in like 5 minutes. So the immediate thing for me is, like, once we, because in my agency, we build apps, like, we've got a new app spinning up, every couple of months for a new client. And rather than stepping through the process every time of doing all this, it's so much nicer just to, like, know these commands and be able to wire things up in this way. All right, so we have covered layouts with a page. We might want a component. We could do yarn redwood generate a component. And I don't know, let's call that the hello component. Generating component files, they go in the components directory. Here's hello, again, storybook story, a unit test file, and then the component itself gives you some default text, so let's just actually keep that. Then within, let's say, the About page, we can call for that component. So maybe we take out this stuff and we ask for the hello component. We can bring it in this way. Hello comes from components, hello, hello, and that comes through there. Perfect. So we've got components coming in. So that's the 3 levels. We've got a layout wrapping our entire page. We've got a set of pages that can go within a layout, and then we've got components that can go within that. Where it gets really cool, though, is if we start to work with the API side. So I'm going to show you to start this file called schema.prisma. So if you're not familiar with Prisma, it is a type-safe way to do database access amongst other things. With Prisma, you can hook up to any database you might be using, like Postgres, MySQL, SQL Server, MongoDB, any of these. And Prisma gives you kind of a type-safe database access client that sits on top of these databases. You start by defining your models. So you might do a model. Let's call it conference. And conference has an ID that's a string. We're going to say that this is the unique ID for this field. It's got a default value of a CUID, which is a collision-resistant unique ID. The conference is probably going to have a name. Maybe it's got a start date, which can be a date time. Maybe it's got an end date time as well. Then I always do like created at, so that I can track like how things are changing. Created at will be a date time as well. And we can default that to now, because when a record gets created, we want to put the current timestamp on it. And then we can have an updated at field as well. So that's date time. And we would want to say that Prisma should, anytime this model updates, anytime a record updates in this model, it should just put a new timestamp in this field. We do that with this decorator called updated at. So we're not going to do super deep dive into Prisma in this lesson. I've got some Prisma material out there if you're interested. But it's the data modeling tool that underlies Redwood. And it's very, very nice to work with. Once you have your data model, you can do another command, yarn redwood prisma db push, to get ourselves wired up with a database against this data model. This is going to create, I'm using SQLite, so file system-based database. It creates a temporary, I guess call it temporary database called dev.db. And now it's got my data model. I'll do another one, yarn, redwood, prisma, generate to generate the client, we call it, Prisma client. And now Redwood is going to know about the data modeling that's happening within the application. So what you can do, I mentioned in the slides, you can generate an SDL. That's going to be your schema definition language that's going to give you your API to allow you to access your backend. But you can also do this, which is really cool. You can do yarn redwood scaffold and target conference, the name of the data model that we want to scaffold against. And scaffold, oh, I need to generate scaffold. Scaffolding does a bunch of stuff. What it's going to give us is, if we look at the routes file, it's going to give us a set of new pages to begin with. We've got this the set of new pages that gets generated for us. We get a new layout. We get a GraphQL layer made for us. We get a full GraphQL schema against our conference data model. We get, in the services directory, this is where the resolvers for the GraphQL layer live. We get a set of resolvers to do our full CRUD operations against that data model. And if we now go over to our app, and let's just get ourselves back to the start here. Here's all of our new stuff. So we can go to conferences new, and we get a full UI immediately as well. So let's put in a record. We can see how this works. When did the conference start? On Sunday? At like 9 a.m. maybe? I don't know. Let's say it goes to tomorrow. Something like that. Save that, and there is our record. So we can, show the record, we can edit, delete it. So full CRUD operations immediately, just based on a command, which is really cool. This is a kind of a layout perhaps that you're maybe not going to use to its full extent in your actual application. It's a pretty generic looking component, but it gets you, to a great starting point. You can scaffold based on your model, and then you can hop into your individual component files and start editing those to make it do exactly what you want. So plenty of good stuff that Redwood offers. One of the concepts of Redwood is something called a cell, and I'm going to try to just show that quickly. I only have a couple minutes here. But if we're in components and we go to conference, we can take a look at conference cell. And a cell is an interesting concept that is an invention of Redwood. It's a component that exports four things. It exports a loading state, an empty state, a failure state, and a success state. And so what you get out of it is, by virtue of having a cell for yourself that targets a certain GraphQL query, which comes with the cell when you scaffold or when you generate, you're going to get basically a complete story around how you might access data and what happens if there's no data, what happens if your call fails to your API, etc. You get that all for free just by generating that command. So the pattern is like what we do, at CourseLift or in any of my projects at my agency. We will have a model. We target a cell generation against it. We don't really use scaffolding like I showed you too much. We instead will generate the SDL and then generate a cell to do our data access against. And it gives us, so much code written for free, which is again the point. All right, so to wrap things up, let's go back to the slides quickly. I think we only have 2 minutes, so I'm not going to be able to do too much more here. But I will say, this is the take-home message. Redwood does a bunch of stuff that I would be doing anyway, and that I think a lot of us would be doing if we are, creating a front end that talks to a back end. It's just, there's certain things you've got to do. In those scenarios, Redwood has completed that for us, and so it is, I guess, by the set of constraints that Redwood gives us, that we get a lot of benefit. We get a lot of productivity by just opting into those constraints. I won't have time to show this last last video from Tom, but the gist of it is there are certain philosophies that come from, let's say, Rails that have helped to inform Redwood's decision making around the patterns that it implements. And I think that's for the best, because Rails is a well-loved framework that has a lot of these kind of nice developer ergonomics built in. All right, so, and the last point I'll make is, like, I'm kind of, I suppose, in a way, railing against this whole idea of like taking React and making it bespoke for your own purposes, and making sure that it's like super optimized and all that, like only focusing on bundle size, stuff like that. There are legitimate cases for that, but I think that like we don't want to be myopic about focusing on bundle size, let's say, at the expense of focusing on productivity. I think productivity gains can be had by using a full stack framework like Redwood. And consider the downstream implications, things like how quickly will I be able to implement new features? How quickly can I onboard new team members? What's been great at the agency is that we are able to bring in new developers like very quickly. It takes like a day or two for them to get into a project and see what's going on. There's consistency across everything, which is huge. Check it out if you're interested, redwoodjs.com. I have no affiliation with the organization other than that I'm a happy user, but I encourage you to check out and do the tutorial, because it's very thorough. It'll take you through everything that I showed you and much more. And that's about it for today. So happy to answer any questions. I'll be around all day, and thanks for your time today.